since we just all posted all of this registration, so.
Hi.
Hey.
Thanks for coming out. I know it's Halloween. I know we'd rather be at home stuffing our faces with candy. We'll still have some time to do that later, I guess. We'll talk about today's prep work in just a moment. Before that, just one little reminder. I know that some of you demoed the assignments to me last week, and the internet was out, so I wasn't able to check you off when you did. I think I got everybody, but well, actually, I'm pretty sure I missed one or two of you. So if you demoed to me last week, please double check. I am almost positive that I forgot to mark off one or two people who demoed to me last week. So if you demoed to me, just give me a reminder. Make sure I get that taken care of before you leave here today. There's still quite a few people who have not yet demoed. It looks like we're getting closer, but still a significant number of people who have not yet demoed that assignment. So there'll be more time for you to work on that and get help with that today. And I think that's about it. Next week's material has been posted, so if you are wanting to keep up with that stuff, then it should already be up. But this week's material had to do with looking at code that you have not seen before, that somebody else has written for you. And so I've actually got a program that somebody else has written. This program is actually fairly new to me as well. I didn't write this code. One of my students over on campus wrote this code for an assignment that I gave in class a year or two ago. So this code is not super familiar to me either. And so I just wanted to explore this code with you, see if we could figure out what this code is doing together as a group. So if you're faced with this situation, if you've got a bunch of code and you don't know what it does and you want to try to figure it out, what are you going to do? What's the first thing you're going to take a look at? Try to find a main method. There's actually something I would suggest you try to do even before that. But that's a very good answer. A README or some kind of documentation. Some kind of documentation. Now here's a little secret that's maybe not so secret. Programmers do not like writing documentation. They don't like explaining what their code does. They like writing code a lot, but typically find writing documentation to be very tedious. So it's not unusual to have a program with lots and lots of code with very little description of what it does outside of maybe a few sentences. Where can you go to find this documentation? You can find it in a README, which might be a whole separate document. You might find it in the code itself. So you'll notice on this particular file, there's not much. But if I go to one of these other files, this is actually a very large program. I've actually got 1, 2, 3, 4, 5, 6, I got 7 files here. But if I go to some of the other files, you'll see that, oh wow, this is actually all documentation that's been given to us about this particular file. So it includes a lot of information. Are you going to sit down and read it from top to bottom? Maybe not, but I might read the first part, the first couple parts. Usually the really, really important stuff will be towards the top. So you can take a look at that and get a feel for what's going on, and then kind of move on and read the rest as you need to. Read the rest as it comes up. So this says it's a standard drawing library. It provides basic capability for creating drawings with your programs. So a simple graphics model that allows you to create drawings consisting of points, lines, and curves in a window. So we're actually going to be drawing stuff to the screen. This is something that we haven't actually seen a whole lot of before. We did have 1 or 2 programs that popped up a window and drew some stuff on the screen, but we haven't done a whole lot with it. This file, this class, its whole purpose in life is to allow us to do drawings, to make things draw on the screen. So we know already that this program is going to draw some stuff on the screen. What is it going to draw? I'm not sure, but we know it's going to draw something. And if you look at some of the other files, there's one here called game. You'll notice that this one isn't quite as verbose. It's not documented quite as much as the other one, but it does have a little bits and pieces of comments in here that kind of give us an idea of what's the step-by-step is that's going on. I see collisions, projectiles, building collisions. So all right, I'm getting a feel for what's in this particular program. We know it's a game. We know it apparently involves gorillas, because I see the word gorilla popping up a lot, right? There's apparently buildings involved. So we're already kind of getting an idea for what this actually does. But once we've done that, the next suggestion was to go to the main method and start there. This is where the program starts executing, right? This is the very beginning of the program. So we're just going to start at the beginning, just like we were reading a book, and start reading things line by line. Now, unlike a book, computer programs are more like Choose Your Own Adventure, where you have to skip ahead 10 pages and then go back and then skip ahead and then go back. So you're jumping around all over the place instead of just reading it line by line. But here you can see in our main method, the first thing we do is we start the score at 0. There's standard draw. Remember, that's what was in charge of the graphics of drawing things. Set canvas size. So we're setting the size of the window that we want this thing to be working with. And then what are we doing here? This line, what's that doing? Creating a new game. Creating an instance of the game class, and then calling the play game method. We're just kicking it off. It's actually a very good main method. Main method should be short, should be simple. There should not be tons and tons and tons of code in your main method. Think of the main method as like the control center. I always picture Star Trek in my head when I'm writing a main method. It's the chair that the captain's sitting in. There's not a bunch of stuff there. You can look around and kind of see other things that are going on, but it's not doing a whole lot of work. Okay, so really, you see that what it does is it creates this instance and then goes off to this game class to actually play the game. And so somewhere in here, there is a method called play game, and it's kind of a big file. You'll notice that there's a lot of work going on here. So Control F is your friend. Play game. So there it is again, but that's not the play game method, right? We see it's some different method called respawn. Play game. Oh, okay, here we go. I found the definition of play game. And so this is what's going to happen next. I'm not going to go through this whole program. That would take us far too long, but we can kind of get a feel for what this program is doing by following along this particular method, creating an array list of buildings. Well, what is a building? Where would I go if I wanted to figure out more information about what a building is?
Building class.
I've got a class for it. I've got a class for it over here. So a building has a number, apparently, a color associated with it. X, Y, that sounds like a coordinate, right? A position. And a height and a width. So it has a size. What can buildings do? If we come down here and take a look, I see a setter for the position. I see a getter for the position. I see that it can draw itself. I can get the height, right? There's not a whole lot going on. So I've got some buildings. Down here, I've got some gorillas. I'm making some gorillas. And if I look over here, I have a gorilla class too. I can take a peek and see what the gorilla class has. Okay. A position, X, Y. A projectile, so there's some kind of missile, I don't know, happening. Some kind of flying object happening. A player ID, so what gorilla is this? Are you gorilla number 1, gorilla number 2, gorilla number 3? And more getters. Very similar to the building class. All right. So one other thing that you can do, it works very well for this particular program, although it won't work well for all programs, is you should try to run it. Try to run this program and see what happens. And that can give you a lot more of an idea of what's going on. So let's go ahead and run this program and see what it does. You'll notice that the first thing that it's doing is, I know it's a little hard to see because of the poor color choice, but it's drawing rectangles. Oh, there's a better color. It's drawing rectangles on the screen. And based off of what we've seen in the code, those are probably buildings. It looks like a skyline, kind of. So it's drawing a skyline. This takes a minute. There's actually probably, this is, if I were grading this, I would tell this student that this takes too long. They need to find a way to do it faster. But it'll be over soon. There's only so much space left. Maybe one more. All right. Okay, so it made some buildings. And what's it going to do next? There's a black square. All right. And now down here it says, hey, look, enter an angle in degrees. So I'll just pick an angle. Enter a velocity as a number from 1 to 100. And then let's see if I can resize this a little bit so that we can see what's happening. And it threw a little circle. Do you see that? Although it looks like there was another problem. Well, let's just try it again. Let's just keep going and see. 35. Okay, there we go. That's better. That actually was not a bad throw. It looks like I'm trying to hit the other one, right? So these black things then must be gorillas. They don't look very much like gorillas, but you know, this was a computer science project, not an art project, so we were very lenient in that particular regard. The reason that we say that they're gorillas is because this is actually a game based on a game that I played growing up. No, not Donkey Kong. Here's a video of what the game was meant to represent. So, oh, we have sound too. Nice.
Yes, classic.
So those look like gorillas, kind of. And there's our buildings, right? And our two gorillas. And so up at the top, it's waiting for them to type in. This is a video, so I can't type in the angle, but whoever's playing this is going to type in the angle and the velocity, and then they throw bananas. You can hit the sun. The sun makes a frowny face if you hit it. But that banana was thrown a little bit too hard. But if it were to hit something, maybe this guy will actually hit something, then they explode. So they're exploding bananas. I don't know how it works. But yeah, that's the game. You're trying to hit the other person. Pretty simple, pretty straightforward game. But that's not really the point. I'm sort of sidetracking a little bit. It's a fun game, or at least it was to me back in the day when I was playing it. And so this is meant to be a replica of that. Now, there's a lot more going on to this, right? Think about what that game actually needs to do. You know quite a bit now to be able to consider what a program like that needs to do. For example, when I'm doing this stuff down here, asking for angles of velocity, what's that? How am I doing that? How am I getting that information? What am I using? A scanner. So there's a scanner somewhere in here that's asking people to type stuff in, right? There's a scanner somewhere in this code. I'm not sure exactly where. If I wanted to, though, I could find it. I could go through the code and figure out where it is. It's drawing those little bullets that go across the screen, but eventually I have to check to see if I hit something. So there's some kind of a collision detection going on, which is, it's a lot of math, quite honestly. It's a lot of physics. I don't know when the last time is you guys took a physics course, but you know, things make arcs as you throw them through the air. So somewhere in here, I would imagine, probably in this projectile class, there's perhaps a somewhat complicated, maybe not terribly complicated, physics. Yeah, here's the physics equation right here. Angle, velocity, pi. Oh yeah, they're doing some physics right now. So they're computing the trajectory of that projectile as it moves across the screen. But we actually figured out a lot of that stuff before we even looked at the program, before we even started it. We had a kind of a good idea of what was going on. It's not always going to be that easy. This is, while it's a big program in terms of what we've done so far, it's actually a relatively small program in terms of the kinds of programs that large companies are writing on a regular basis. This is pretty small. But the ideas still stand. Take a look at the objects. Take a look at what information you have available. Now, the nice thing about this program is that everything is nicely named. That will not always be true. That's when things get a little bit more difficult. Here, all of the objects have nice names. All of the variables in the objects, for the most part, have nice names, which makes it easier for us to figure out what's actually going on. Unfortunately, that's not always going to be the case. But were there any questions about this, or about examining code that you haven't seen before? It's a good skill to have. Consider that it's just like learning a foreign language. I can speak French relatively well, but speaking French and reading French are two different things. They're two very different things. Having a conversation with somebody is useful. Being able to read road signs as I travel down the street is another useful skill to have. So, being able to write code, certainly very useful, certainly a great skill, something that we're trying to teach you, but it's not always about writing code. Code comprehension is a very important skill as well. And so what I'm going to do, the next thing on my agenda, I'm going to give you access to this code. This code's actually online. I'm going to show you how to grab a copy of it, and you can actually change it, modify it, and play around with it, and make it do other stuff if you want to. We're going to use a tool called a version control system to distribute this code. In particular, we're going to use a tool called Git, and you've all been using Git, kind of, since the beginning of class. GitHub is where you've been putting all of your assignments, right, in order to turn them in. But we haven't really been using it for, we haven't been using it in the way that it's intended to be used. So let's talk about Git for a moment, and I want to show you some things that you can do with Git that will be very important, especially as you start working on larger projects, especially as you start working with other people. Despite the stereotypes, programming is not just some guy sitting by himself in a dark basement writing code for the whole program. It's a team activity, right? You're going to be working with lots of people. And so we need tools to help us coordinate how people access programs. So some of you may have been in this situation before. My wife talks about this all the time. She's got some files that she works on at work, like Excel spreadsheets, I think. She does a lot of stuff with Excel spreadsheets. And sometimes, she'll grab one of those spreadsheets and make some changes to it. But unbeknownst to her, her colleague down the hall or her boss or somebody else also grabbed a copy of that spreadsheet and made some changes to it. And now they have a big problem because they both made changes to the spreadsheet and they have two different copies now. They have two different versions of the spreadsheet that don't agree with each other necessarily, right? Has that happened to some of you before? It's a really annoying thing that happens from time to time. And so what version control is an attempt to try and, we can't really prevent that from happening, but we can detect it, and we can have tools that will help us reconcile that situation when it does happen. That's called a conflict. When we have two different copies of the same thing, and we don't know which one is correct, or maybe they're both kind of correct, and we want to merge them together somehow. It's called a conflict. And so what version control does is it keeps a central copy of your code, of your programs. The central copy, you all have one. It's on GitHub. So if you go to GitHub and you look at where all your files are, the ones that you've put on there right before you submit, right? That is a centralized copy. It's on the internet. It's on your computer. It is on the internet. We call that a repository. That is the what we would call the upstream repository. It lives on the internet. We can grab a copy of that and put it on our computer. We don't actually remove it from the internet, right? We just take a copy of that and we put it on our computer. We would call that the local copy or a clone of whatever's on the internet. The nice thing is that it's not just you that can make a copy of that. Anybody who wants to can make a copy of that as well. So I could have a copy, and you could have a copy, and you could have a copy, and you could have a copy. Whole bunches of people could have copies of that code. But remember, the one version, the definitive version, the one that counts, is the one that's on GitHub, the one that's on the internet. That is the most important of them all. And so then, let's say I want to make some changes. I'll make some changes on my end, and I'll perform what's called a commit. A commit is saying, I made some changes to this code. I want to commit those changes. I want to make them a permanent part of history. This is a thing that happened. I want you to remember this forever. I am making a new version of this program. And once I make that commit, I can push those changes back up to GitHub, to the internet, so that then everybody else can see the changes that I've made and pull down a new copy, a fresh copy to work with. And so that's sort of the process. Let me show you how that process actually works. And you're welcome to follow along with me if you want to as I go through this, so that you can grab a copy of this as well. The first thing I'm going to do is I'm going to close this project. Now, if you're working on microblog, you might be like, well, I don't want to close that. I'm still working on it, right? It's okay. I promise you, it's not going to hurt anything. Your work will all still be there. I'll show you how to get it back later if you need to. So I'm going to go up and hit Close Project. And it should bring you back to this beginning screen of IntelliJ. All right? The next thing I'm going to do is I'm going to come down here. There's an option. It says check out from version control. And I have to choose what kind of version control I care about. So in this particular case, we're using Git. 99, I don't know, maybe that's a little high, 98% of the world. It's a large percentage of the world is using Git. Subversion used to be the most popular version control. When I was going through college, when I was first starting out, that was what everybody used. It's kind of fallen out of favor. Git is the latest and greatest. It may go away eventually too. Who knows? Yeah.
Was subversion just another online?
Yep. Okay. Same general principle. It's just the way you interacted with it was a little different. Git can do a little bit more than what Subversion can. It's newer. But almost everybody uses Git. I would be surprised if you went to work somewhere and they use anything besides Git. I'd be very surprised. Now, I've already done this because I use IntelliJ on a regular basis, but since this is your first time, you probably need to hit this button to log into GitHub. So that's just your GitHub login information. I think it's your email address, whatever your password is. You'll have to do that to be able to access anything this way. And then once you've logged in, you'll notice a couple of boxes up here. One of them says URL. So this is looking for the web address of the repository. Remember, the one that's online, that's the definitive version. That is the golden copy. So it wants to know what the web address is of the repository that you are looking for. And so the next question is, well, how do we figure that out? Well, if you go to GitHub, this is actually the repository page for the Gorillas game that I just showed you. I made this before class. This is the GitHub repository for the Gorillas game. You have a page that looks very similar to this, right? For all of your stuff. Okay? And so whatever repository you want to check out, there's a big green button over here, clone or download. But actually before, I guess you need to know how to get to this page first, right? So you can go up here to the top and do a search. Gorillas. You might need to search for, my username, which is Dig Shake, like Doug Shook, but not Dig Shake. So if you do, well, you couldn't find it, huh? Oh, search all of GitHub, sorry. Did I make it public? I hope I did. Okay, type Dig Shake first, I guess, and then Gorillas. Yeah, there it is. or you might be able to see the address up here at the top in my address bar if you're really looking for it. But whenever you get to one of these pages, you can hit this green button over here that says clone or download, and the address that we want is in this box right here. Notice it ends in .git. That's how you know that you found the right one. Okay? And so then you can copy this and go back to IntelliJ and paste it into this box right here. This is the address of the repository that we want. This second box, the one marked directory, is where do you want to put your copy on your computer. So it might give you a suggestion that's okay. It's mad at me because I already have a copy. So it doesn't want to, erase the copy that I already have. You can change the name of that directory if you need to make it happen. And then once everything looks happy, you can go ahead and hit clone. And it's now download. Well, it was very quick. There's not a whole lot of stuff. It downloaded the copy that we had on GitHub onto our computer, and it's now asking us if we want to make a new project for that code. And the answer is yes. Yes, I do. We now have some questions that we need to answer. Sometimes you'll get code that's already ready to go with IntelliJ. Sometimes you're just going to download plain old code and you have to create a new project for IntelliJ. It's always safe to do this option. But in some cases, if you know that it's one of these things on this list, it can be faster. But we're going to create a project from existing sources and hit next. We can give this project a name. This is actually, I know it's been a very, very long time, but during the first or second week of class, when you created your Codergirl project, this is the same process. It's the same thing that we're doing. So give your project a name. Here we go. It found the source files. It found Java source files. That's good because there's Java code. It's looking for libraries, and there are none, so that's okay. We can just keep hitting next. All right. It's going to make a folder for us called Gorillas3. That's fine. So we can go ahead and hit next. It wants to know what version of Java we want to use. We had to set this up at the beginning of class as well for a lot of you. So it found Java version 1.8 for me, which is fine. If you're using 9 or some other version, that's fine as well. We can hit next. No frameworks detected. Okay. Hit finish. And now it should pop up. It should pop up a new project, and if I start going through and I look in the game folder, there's all the code. I grabbed a copy of that, and it's now on my computer. Are there any questions? I know I clicked next very fast, but we didn't really need to do anything on those screens. Were there any questions about that process? So that's only one direction. I took code that was on the internet and I made a copy of it on my computer, and now I can do stuff with it. I can run the program, I can change the program, I can do things with the code that I have on my computer. But we need to talk about the other direction now. I want to make this better. I want to improve some things, and then I want to take the changes that I've made and I want to put them back up on the internet so that the permanent copy, so that the copy that's online is reflects the changes that I've made. So we'll go in here and we'll make a little change somewhere in the code. It doesn't really matter what the change is. Where's that scanner? Here it is. Well, oh, there's the scanner, yeah. I'm just gonna change some of these things. Just change some of this text. It won't actually break anything. I'm just gonna make a couple little changes just to say that I changed something and save. In IntelliJ, now that I've made some changes, there's a menu up here called VCS. Stands for Version Control System. So if I hit this menu up here, I can go to the option that says commit. And it will go and it will find all of the files that I have changed. All of them that I have changed. In this case, I just changed one file, game.java. It'll even show me what lines I changed and what the changes were that I made. So on the left, I know it's a little hard to see. Let me see if I can make this bigger. Maybe. My text is really big. That's why it's hard to see. So on the left, I can see what the old version was. And on the right, I can see what the new version is. It's showing me the changes. It's keeping track of the different versions. Okay? So I have the old version and the new version. We typically like to give a message. What are the changes that I made? Give a description of the changes that you actually made to this program. So updated in-game text, right? I didn't really do much. I just changed a little bit of the text that was in the game. And then down here at the bottom, there's a button with an arrow next to it. If I click the little arrow, there's an option that says commit and push. So commit is like saving your work on your computer. It saves your work on your computer, but it doesn't send it to the internet. That's what a push is. A push sends your work up to the internet. So I want to commit and push. I want to save my work and I want to send it up to the internet. All right, it tells me there's problems, no errors and 11 warnings. I think that's okay. I'm going to go ahead and continue committing and pushing. Hit push. All right, push successful. If you want to know if it worked, I can go to GitHub. I can refresh the page. And now you'll notice actually this message changed, right? Updated in-game text. That was the message that I typed in. That was my commit message. And if I go inside of this folder and take a look, you can see, right? Updated in-game text 33 seconds ago. It saw the change. It received the change that I sent to it. It's updated now. And you can go in here and actually take a look and see the new code has made it, if you want to. But the power of that, the nice thing about that is now that anybody else who is working on that can also see that change. They can see that update that I've made. I don't have to send an email to everybody working on the project saying, oh, here's the new stuff that I made. No. It's all on GitHub. They can all just grab the new changes when they want to. So I would really like to see you using your GitHub repository in this way from now on. You're welcome to play around with this project if you want to, but you can do the same thing that we just did with your GitHub page. You can do the exact same thing for the one with all of your assignments if you want to. Right? Go to GitHub, go to the page with all of your stuff on it, click that big green button, grab the address, and do the same process. And now if you want to submit assignments, you can do it directly through IntelliJ. You don't even have to go to the website anymore. You can just do it all through IntelliJ. I know it's kind of a lot to get. The learning curve for Git is kind of steep. I've really just scratched the surface of what it can do. This is the absolute basics, but sooner or later this is going to become expected of you in your workplace. This is how large teams do work on a regular basis. Are there any questions? Any comments? If you have questions about getting this set up on your own machine, I'd be happy to help you out with that. I would really like to see people submit assignments this way from now on. So I'm going to be encouraging you to do that. Are there any questions at all?
Do we need to download something in order to do this?
No.
My computer was saying that it made me download some like developer tool thing.
Same with mine.
Really?
Yeah.
Okay, well then maybe the answer is yes. I don't know. What happened when you hit yes? Did it?
It took me to the SourceForge download Git OSX installer.
Oh.
And now it's downloading.
Okay. I'm sorry about that. I did not know that that was a necessary step. I apologize. Yeah, but of course, if you're having trouble, please let me know. I am recording this, so I'll put this video up so you can follow through the steps later on if you need to. If you need to go back to refer to them. Was there another question?
Would you refer to what we just did as pulling from Git, or is that?
Yeah, we actually didn't do a pull.
Okay.
So that's a good question though. That's the opposite of a push. So push is me taking something from my computer and putting it online. A pull then is going and asking GitHub, hey, are there any new changes? Has anybody made any changes to the stuff that you have? Because I want those. Please give those to me.
But grabbing the initial code, like Gorillas from your repository, that.
Yeah, that's actually called a clone. So the very first time I started with nothing, so I made a clone. That's the first step. And then the next time I want to get stuff from online, I don't need all of it, right? I just need the stuff that's changed. So it's called a pull. It's a little bit different. But I can show you that actually. That's something, I'm glad you asked. That's something that I can show you as well. If I go to the Gorillas page. Now, I'm not a huge fan of doing what I'm about to do, but for the sake of an example, I'll do it. You can actually edit things directly on GitHub. I don't recommend it except for, you know, very, very trivial things. You should not be editing stuff on GitHub on a regular basis, but you can do it. So I'm going to make a little change to GitHub right here. Just put in a little comment that says hello, nothing special. And I'll make a pull message, or I'm sorry, a commit message, and commit these changes. And now consider, right, the copy that I have in IntelliJ on my computer is different than what's on the internet, right? It's different than what's on GitHub. So there's a mismatch now. So I need to get those changes from GitHub. I need to go to GitHub and say, hey, give me all the changes that you have. So the same thing, I'll go up to this version control menu. There's an option for Git, and then down here there's an option that says pull. So I'll go ahead and click the pull button. It's pulling changes from origin. It found a change in the file main.java. That's where I put that comment. And now if I go into main, I see, all right, there's the comment that I added. Great question. So when you all get hired as programmers and you're working on a team of people on a single project, right? You come into work first thing in the morning. What are you going to do? You're going to pull right away. Pull. Pull new changes, because if anybody was working overnight or if anybody did something after you left yesterday, you want those new changes before you start making new changes of your own. You always want the most up-to-date thing. And then if you need to go take a break, maybe you're going on lunch, or maybe you finished something, you've finished a part of the program, you've made a change, commit it and push it back so that other people who are working on that see those changes as soon as possible. Don't wait. Don't sit on them, because then you run the risk of conflicts, which is where I change something, somebody else changes something, and then it's like, well, which one is the right one? Which one do we want? I can actually show you that as well. Let's say I make a change to this and commit it, and I'll go on to GitHub and make another change to that same thing. Oops. So I just changed it online. It says hey online, and on my version it says hi. I'm going to commit this too. So now I have a problem. This is a very trivial example, right? But you see what the problem is. I've got two different copies, and it doesn't know which one is the right one. It could matter. For a comment, it doesn't matter, but for an actual line of code, this stuff matters, and it doesn't know which one is the quote-unquote correct one. So you'll notice I tried to push and it says I can't. Remote changes need to be merged. That means that the one online has changed and I haven't gotten that change yet. So it's not going to let me make any changes until I have the most recent stuff from the internet. Yeah.
Do you get to choose who's the survivor of a merge, or?
Yes, you do, and I'll show you that in just a second. So, all right, it told me I can't do my changes until I grab the new ones, so I'll come back and do a poll. That should get me the changes from GitHub. And now, all right, we've got a problem. Files merged with conflicts. We've got a problem now. There's two buttons here. I can accept yours, that's the one that I have on my computer, or I can accept theirs, that's the one that's on the internet. So I can pick which one I think is correct. Which version do I want to keep? Or maybe I need to do a little bit more, maybe it's not so easy. Maybe it's not just, maybe I want to keep some of both, right? I want to keep some of my stuff and I want to keep some of their stuff. Well, I don't have to do either of these. If you'll notice, the file has changed. And I've got both versions in the same file now. Head, that's saying this is the one you had on your computer. This long string of numbers, that's the stuff that came from the internet. So now I can pick. I can take some stuff from this version, I can take some stuff from this version. Whichever I want, I need to pick and choose, and I can delete the rest. So just get the rest out of there. All right. This version wins. I'll take this version, and then to resolve the conflict, I just commit again. Make a commit, and everything should be okay. Unresolved conflict, so I thought I did resolve the conflict. Hang on. Did I not? I thought I resolved the conflict. Okay, you have to add the file. So what did I do? I went down here and I hit add first, and now I should be able to hopefully commit, push this. Yep. Commit and push, and we're back in a stable state again. There's no longer two separate copies, there's just one copy. They both say hey. Oh man, I could go on about Git for a long time. Let me just show you one final thing. Let's say I made a change and I screwed up. I was like, oh, I changed this thing, I really shouldn't have changed that thing. I actually wanted it to be the way that it was before. GitHub keeps track of all of the changes that you make to these files. So if I go to the file that I was just playing with, for example, and I hit the history button, here's all of the changes that were made to this file. And I can look at them. I can look at these versions. There's the one that we started with a few minutes ago. So I can go back and find that. That's why making commits frequently is a good thing. I don't want to make one giant commit at the end of the week with everything that I've done since Monday. I want to make lots of small commits periodically throughout the day, a couple times a day, probably, depending on how much work you get done, I guess. And so that way, if something needs to be undone, I can easily find those changes, undo them. So Git is just an extremely, extremely useful tool. It's not going to make you a better programmer, but it will keep you from destroying your work, or maybe even more importantly, destroying somebody else's work. If you destroy your own stuff, it sucks, but it's like, okay, I'll fix it. If you destroy somebody else's stuff, now you got to fix it, and they're mad at you, so that's even worse. We don't want that to happen. And so Git prevents stuff like that from happening.
I'm sorry, I got lost when you were committing the first game. But so do you have to go, can you just commit it initially through IntelliJ the first time, or do you have to go into, you have to copy and paste it into Git for the first time?
Oh, okay. So if you're just starting out, That's a good question, actually. So you'll remember when you first started class, what you did is you got onto GitHub and you created a new repository. So if I create a new repository, test repository, right, and create it, it's empty. There's nothing in it. There's nothing in it. I can still clone this empty repository and then put stuff in it and then commit it back. And now it's no longer empty. I would recommend actually doing that through IntelliJ. I don't like using GitHub for making changes to repositories unless they're very small, trivial kinds of changes. If I'm adding new files, if I'm making large changes to things, I want to do that through IntelliJ. Because IntelliJ has a lot of stuff that's going to prevent me from making stupid mistakes. GitHub is not going to stop me from making stupid mistakes. It's going to do whatever I put in there. Yeah, so I mean the process is the same. I can copy this address and go to IntelliJ and check out this project from version control by pasting it in the box. Create an idea project, sure. There's nothing in this repository. Remember, it's brand new, so it's empty, right? There's nothing in it. But now it's here, and I can put stuff in it, and then I can commit those changes. I would highly recommend that you go through this process with your Codergirl repository, the one that's got all of your assignments in it, and then use that repository for the rest of the class. That's what I would highly suggest that you do. Anytime you make a new file, you want it to be put in your repository. Another good thing that repositories can be used for, they become portfolios. So when you go to a job interview, when you go to try and get jobs, people are going to say, well, what have you done? What kind of work have you done? You can send them a link. Here you go. Here's my GitHub. Here's all the projects that I've worked on. Go take a look. A lot of people will put their GitHub address on their resume. In fact, I'd say it's probably a red flag if you don't have some kind of GitHub or other repository address on your resume if you're going for a programming job. For entry level, if you're just starting out, people probably let that slide. But if you've been in the industry for more than a couple years, people are going to be like, well, why don't you have anything to show me? Why don't you have any work online that you can show me? But even the stuff you've been doing for Codergirl, I would recommend you can show that off to people as part of your resume as you go through the placement process, especially as you start doing the project portion of Codergirl after the end of the year. All right, any other questions before I get out of your way? I know a lot of you are still working on microblogs, so I would encourage you to keep working on that. By the way, if you need to get back to that, close this project, and then on the left-hand side here, you'll see a whole list of projects. So whatever the project was that you were using, I think mine is just called Codergirl. Just select that project again, and it should have all of your Codergirl stuff. If you need help, just let me know, and I can help you out, get that back. Yeah, just let me know what you need. And also remember, double check if you demoed last week. Just double check for me real quick, make sure that it got marked off, and if it didn't, let me know so that I can take care of that.